Hello everyone, welcome to my channel Learn with PR and welcome back to our linked list series in C++. Today we are going to learn about time and space complexity of our different operations in linked list. So let's start. We have already understood how all types of linked list work: singly, doubly, circular and circular doubly. But one big question remains: which one is faster and what is their time and space complexity? All right. So let's break it down in the simplest way possible. So first, what is time complexity? So the time complexity tells us how much time an algorithm takes to run as input size increases. जैसे जैसे आपका इनपुट साइज इंक्रीज होता रहेगा वैसे वैसे आपके एल्गोरिथम की टाइम कॉम्प्लेक्सिटी बढ़ती जाएगी. That is a simple one. Okay. Simple understanding for me, you can simply say, yes, it does not basically mean actual clock. Okay. So it means a number of steps per operations the algorithm performs. जितने भी आपने steps perform करे हैं, जितने भी operations perform करे हैं, that algorithm performs, that is we can say the time complexity is. Suppose 5 elements are there, so 5 steps you perform. 100 elements, so 100 steps you perform. So as the input increases, steps increases, so this is the time complexity. All right, we have big O1, big O log n, big O n, big O n square, and 2 power n, that's exponential, that is very slow. Okay, so this is how we can do it. What is time complexity? That is simple one. Okay, now tell me, let's tell about space complexity. So what space complexity is? Basically how much memory an algorithm uses as input grows. Okay, जैसे जैसे आपका input grow हो रहा है वैसे memory कितनी ले रहा है आपका algorithm. That is a simple one, that is a space complexity. So simple understanding में you can say extra memory required during execution, that is the time complexity. Suppose if we store 10 elements, the memory we required for 10 only. 100 elements we required 100. If the n elements, so we go n space you will have. Okay, so this is what time and space complexity. I have already discussed that thing in my previous video. I will share a link, please check that before. Okay, so in a linked list, basically each node stores data and pointers, as you know very well, right? We have already discussed that thing, right? So here I am first writing a singly linked list. So what is singly linked list? There we will see a node. In that node we have only two kind of data, that is data means whatever the kind of integer, float, double, na character, whatever, and then the node of the next node address you have to store, that's you need a pointer. Okay, so if you are saying we are performing inserting an element at beginning, means in a first position we are inserting that node. Okay, that means when you are inserting it, that means you will go only a constant time, that you can say big O one. So the time complexity when you want to go है ना in a first location, then you will get first location very first, पहले ही मिल जाएगा. When it will you are finding that position in very beginning, that means what, that is the first location. एक ही बार तो करोगे operation perform, that is done. So this is how you can say big O one, only one time you will go inside the node and will update that thing, है ना. There is no looping, so that's why it's a big O one. The time complexity when you want to insert a node at a beginning in a singly linked list, that is a big O one. Okay, let's talk about inserting at end. अगर हमें insert करना है last में, then we have to traverse ना, we have to go one by one every location. We'll check what temp next is not equal to null. If it is true, then we'll go inside. That means we have to traverse till last node we found. हमें जब तक लास्ट नोड नहीं मिल जाता तब तक वी हैव टू ट्रैवर्स. यस, so that means we are going how many times? N nodes we are going. That means the time complexity become big O n. Okay, the time complexity when you want to insert at last in a singly linked list, that is big O n. Okay, so this is how we can write it. Now next, when we want to do at a specific position, a singly linked list, we are performing three things here. That is beginning में insert करना है, end में करना है, and the last position means any kind of position. So when you are saying the position means you are saying, suppose I want to add a new node at the third position. तीसरी location में मेरे को add करना है, right? So first you will check where till मतलब हमें कितना ट्रैवर्स करना है, n टाइम्स करना है या फिर हमें पोजीशन करना है, पोजीशन जो आपने दिया है। अगर मैं n टाइम बोल रही हूँ दैट मीन्स अगेन वी हैव टू ट्रैवर्स लास्ट तक, राइट? अगर आपने कहा देयर इज अ 5 नोड्स इन अ लिंक लिस्ट, 5 ही नोड्स है, मुझे फिफ्थ लोकेशन में ही चेंज करना है, तो मतलब मैं 5 टाइम्स जा रही हूँ ना, दैट मीन्स n टाइम्स वी आर गोइंग, सो बिग O n, राइट? If you are saying कि I want to do it at a beginning, मतलब first position में I want to change, that is a big one, okay, right? And if you are saying in a middle, some middle means third location में I want to provide, है ना, a new node, so that means this is a big O, three times you are going, right? Three times you are going, so that means you have to take the worst scenario for a means there is a three kind of scenarios. You are going big O n, right? You are going big O one, and the last is you are going three times only. That means half, you can say n upon n by 2. That is a log n you are saying. So we have to take who is greater in these three things. Big O one, big O n, and big O log n. That you can say big O n. So that's why the time complexity for this insertion at position in at any specific position, that you can say big O n. All right, so this is a time complexity of your inserting an element at a end, at a beginning, and at a specific position. All right, now let's check out if you want to delete from the beginning. अगर मुझे beginning से ही delete करना है तो मैं पहले ही location में तो रहूंगी, पहले ही node में हम रहेंगे, right? If you are saying हम पहले ही node में अभी यहाँ पे ही है, तो that means we have to delete that only. It means what? We are not going n times, we are not traversing anywhere. That means time complexity become bigger one. All right, this is a simple one. Again the same scenario for deletion at end. Deletion at end means what? That हमें last में जाकर उसको delete कर देना है. That means still we are going traversing, still we are going one by one in each locations, right? That means we are again traversing, so we go n, right? How many times we will go? N times, no? We have to find the second last node, right? So that we can say we have to go second last node, that's nearly equal to, approximately equal to your n, right? So big O n will be time complexity. When you want to delete a position, position में किसी position में आपने बोल दिया कि we have to delete fourth index location, sorry, fourth position, right? That means you have to still go till n times, right? So big O n. Okay, this is a very simple one. In a singly linked list, searching is also there, right? So searching के three cases आ जाएंगे. If you want to search the first location node, okay, so that means big O one. If you want to if you want to search the last node, that means a big O n. Okay, last node को search करना तो हमें traverse again करना पड़ेगा. So big O n we are going. Okay, and when you are saying in a means in a third location, two location we want to search, that is you can say big O log n. You can say we are going half time only, no? हम half ही जा रहे हैं, right? But we have to consider the biggest. We have to consider the worst, you can say. Okay, so that's why I'm writing here worst condition as time complexity big O n. Okay, when you want to display, that means when you want to traverse again the same thing. Traverse we have to go one by one each location again. Time complexity become big O n. All right, now let's talk about the doubly linked list. So what is doubly linked list? Basically in this we have three kinds of data in a node. The first data is a simple value you can store. It can be integer, float, double, character. Okay, and we have previous pointer and a next pointer. So we have two pointers now. Okay, so इसमें space बढ़ जाएगा as compared to your single linked list. We will talk about later space complexity के बारे में. Right now we are talking about the time complexity only. All right, now if we want to insert at a beginning, हमें insert करना है beginning में, then what will be the time complexity? दैट मीन्स बिगिनिंग में पहले ही नोड को हमें इंसर्ट कर, पहले ही पोजीशन में हमें इंसर्ट करना है. दैट मीन्स व्हाट, इट विल नॉट गो एनी ट्रैवर्सिंग, इट विल सिंपली से बिगो वन टाइम कॉम्प्लेक्सिटी. व्हाई? बिकॉज ओनली वन टाइम वी हैव टू गो इनसाइड लिंक लिस्ट, right, as you found the first node. Again the same scenario for the insertion at end. Last में insert करना, that means again the same scenario that we have to traverse. Where we are traversing? While loop we are writing here. Okay, so this is how we can do it. I'm making a function here. I have already discussed all the functions, how we can create functions, how we can create insertion at end and beginning in every type of linked list. Please check that video. We have a full playlist. Okay, so I will also provide you link in the description for a full playlist of linked list. All right. So this is how we can traverse, right? We are traversing again, so the time complexity will become big O n. All right. Now let's talk about this one. This is what y means. We are inserting a node at a specific position. So when we are saying this, that means specific position may at least it will go at least, if you are saying first may, end may, and in a specific position may, then we have to take a worst scenario. Okay. Again, it will say the time complexity become big O n. All right. So if you are not understand, you are not getting the point, the time complexity to find out how we can find out, I have already discussed that thing also in my previous video. Okay, I will share a link as well. Okay, हम टाइम कॉम्प्लेक्सिटी कैसे निकालते हैं, किस तरीके से हमें देखना होता है, सो मैंने उसको ऑलरेडी ही कवर कर रखा है. आपको मैं लिंक प्रोवाइड कर दूंगी राइट हेयर, इसमें आपको डिस्क्रिप्शन में भी देख सकते हो आप. ठीक है, और आपको you will get surely get it. Okay, so from this now you just need to check the looping. Is there any looping? How many times it's going? It's a separate loop, it's not a separate loop, it's a nested loop. So you will see that what kind of time complexity will be there if we are using a different types of different kind and types of list loop. Okay, this is how we can say it. So when you want to insert at a position, that again say the time constant will become n, as we have to again traverse till we found the position. We found the position means this for loop we are using. Okay, this one done. Now let's talk about if you want to delete it. So अगर हमें delete करना है beginning में ही, suppose okay हमें delete करना तो big O n ही तो होगी इसकी भी. अगर हमें डिलीट करना है लास्ट को, तो हमें स्टिल वी हैव टू गो फाइंड द लास्ट नोट. कहाँ पे फाइंड द लास्ट नोट? फाइंड आउट वेयर द लास्ट नोट इज. ओके, एंड देन डिलीट इट. सो अगेन वी हैव टू ट्रैवर्स, सो वी गो एन again insertion, sorry, deletion at position. Again we will go time complexity as we go in. All right, like this. Here the example. So delete from the beginning, we go 1. Why? There is no looping. Delete from end, we have to check the last node where it is basically, right? That's why we have to go n by n times, है ना, whatever the n number of nodes you have. So again the time complexity become n, right? We go n. And delete, when you want to delete the position from any kind of position, again we are using here for loop, so we have to take a worst scenario, so time complexity become big O n. All right, now let's check about the circular linked list. So in this circular, basically we have two kind of things in a node. A node contain a new some kind of data. Okay, any kind of data, integer, char, float, double, whatever, right? And we have a pointer. But last node, basically we have to connect it back to the first node. That is only the difference. Okay, that's why it's circular. It's form circle. Okay. So when you are saying when we have to go insert at beginning, है ना, जब हमें इंसर्ट करना होता है बिगिनिंग में, तो हमें लास्ट वाले नोड से भी एड्रेस को चेंज करना होता है. दैट्स वाई वी हैव टू गो इन इंसर्शन एट बिगिनिंग. ओके, फर्स्ट नोड में तो हमें मिल जाएगा, हेड से मिल जाएगा, लेकिन हमें लास्ट नोड को भी तो देखना पड़ेगा, उसका भी तो एड्रेस चेंज करना पड़ेगा, क्योंकि वो कनेक्ट होता है ना आपके फर्स्ट नोड से. प्लीज चेक दैट थिंग, है ना, मैंने ये आपको पहले से समझा रखा है. ठीक है, आप इसमें कंफ्यूज मत होइएगा क्यों इसकी टाइम कॉम्प्लेक्सिटी बिगो एन है. ठीक है ना. एक तो हम यहाँ पे भी आप देख सकते हो हम वाइल लूप यूज कर रहे हैं. हम क्यों वाइल लूप यूज कर रहे हैं यहाँ पर? क्योंकि हमें लास्ट नोड के जो नेक्स्ट के पॉइंटर में जो हमने स्टोर करा है एड्रेस, दैट एड्रेस वी टू चेंज ना, हमें वो एड्रेस भी चेंज करना है, तो हमें लास्ट तक जाना पड़ेगा. सो दैट्स वाई द टाइम कॉम्प्लेक्सिटी फॉर योर inserting at beginning, insert करना है at beginning में, right, in a circular linked list. Okay, that is a big O N. Again, same scenario for insertion at end. That is also same. We have to go till last तक ना, we have to change it. हमें change करना पड़ेगा, right? Now next we have insert at position. We have to take the worst scenario, right? That is, you can say big O N. Okay. Now when you want to insert, that is a big O N in every time. Big O N will be the time complexity. Now in the deletion at beginning, हमें delete करना है beginning को, तो last node के address को भी change करना पड़ेगा, right? That's why we are writing time complexity of big O N. Deletion from end, अगर हमें delete करना है from end से हमें delete करना है, that means big O N we will go, right? Last तक हमें जाना है. Now deletion from position, again big O N, right? Now let's talk about doubly circular linked list. So doubly circular linked list is what that we want to insert at beginning. There we have three kind of data. First of all, the first data for the node contain three kind of things. First, that simple data, that is int, float, double character, whatever, right? And the previous node and the previous node pointer address we have to store, है ना, in a pointer. And next we have to store the next node address inside the pointer. So we have two pointers here and one simple data, right? So when you want to insert at beginning, the scenario in this word that the last वाला node होगा ना, उसका address हमें first node के previous में store करना है, right? और जो first node का address है वो last node के next में store करना है. That is what that is all about. Your doubly circular linked list means it will go forward as well as backward, right? The last node and last node and the first node are connected each other, right? They are storing the address. Okay, हम दोनों का address store कर रहे हैं दोनों के अंदर ही, right? So this is a doubly circular linked list. When you want to insert at beginning, हमें insert करना है beginning में, तो हमको traverse नहीं करना है last तक. क्यों? क्योंकि हमने जो last का address, last के node का address है वो हमने already store कर रखा है अपने first node में, तो हमें traverse क्यों करना है भाई? ठीक है, हमें traverse नहीं करना है, right? So we will simply change it. हम without traversing we are changing it. That is okay. So it will go time complexity as big O1. अब देखो इंसर्ट एट एंड, अगर हमें इंसर्ट करना है एंड में, जब हम इंसर्ट कर रहे हैं एंड में, राइट? सो इसका मतलब क्या है? फर्स्ट का जो एड्रेस है वो हम फर्स्ट नोड का जो एड्रेस है बेटा, वो वी हैव ऑलरेडी स्टोर्ड दैट थिंग इन अ लास्ट नोड. सो y2 है ना, तो फर्स्ट नोड से ही आप उसको लिंक कर सकते हो. वी कैन कनेक्ट इट. हम उसको लास्ट ले लेंगे. लास्ट में हम कह रहे हैं हेड ऑफ प्रीवियस जा रहा है. हेड ऑफ प्रीवियस वो कौन सा है? जो लास्ट का एड्रेस है. सो हमें ट्रेवर्स करने की जरूरत ही नहीं है, हम उसको डायरेक्टली फैच कर लेते विद द हेल्प ऑफ अनदर पॉइंटर, राइट? एंड वी विल डू इट. देयर इज नो लूप. Okay, that's why the time complexity become big O1. All right. When you want to insert at position, so it will be again same. हमें till some node we have to go, है ना, हमें कुछ node में जाना ही पड़ेगा. तो हम we have to take the scenario worst, you can say big O n, right? Now when you want to delete from the beginning, हमें delete करना है beginning से, तो again हमें delete करना है, तो हमें traverse करने की मतलब हमें जरूरत ही नहीं पड़ेगी traverse करने की, right? That means what? The time constant become big O1. Okay. Now when you want to delete from the end, अगर delete करना है from the end, the same thing, big O1, right? When you want to delete from the position, again the time complexity we have to take worst, big O n. So this is all about the time complexity, right? Now let's talk about the space complexity. So how much extra memory is used? That is, you can say space complexity. So in a single linked list we have memory, right? Memory we are using for nodes only. So node contain two kind of data. That means data contain 1 unit, next pointer containing 1 unit. The total per nodes as 2 nodes, right? 2 units. So if you have 5 number of nodes, okay, so every node contain 2. That means whatever the n node you have, that will become big O n. है Here also you can say linearly we are going, with the number of nodes, right? So this is, you can say the space complexity for linear singly linked list is big O n. When we are talking about the doubly, so doubly mein we have two things. We have previous pointer as well and a next pointer as well, and we have data as well, right? So data contain one, next pointer will contain one, so 3 units we require total, right? That means still space complexity for this doubly linked list is what? Big O n, but it uses more than single linked list, all right, because we have two pointers here, right? Now next we have circular linked list. It contains two things only, right? But इसमें सिर्फ एक difference है, there is no null, कोई null नहीं होता इसमें, right? So again the space complexity is what? Big O n, right? So only difference is the last node points to head back, means वो अपने head को ही connect करता है, right? Now doubly, in a circular doubly linked list we have memory for data node only. We have three kind of data here. Pointers we have used, means a next pointer and next pointer we have, and uh, we have next pointer and we have previous pointer. Again the same scenario, okay? So here one more node you have to write. Okay, here we will say 3 units, right? And space complexity again become big O n, right? So the memory grows linearly, right, with number of nodes, all right? So this is how you can write, this is how you can simply say space complexity as well as time complexity, okay? So I must say that in every kind of linked list, whatever the operation you are performing, the main funda to find time complexity in a linked list is what? Whatever the entire logic comes down to just one thing, that do you need traversal or not, okay? So the golden rule is what? If traversal is required, that means big O n will be the time complexity. If no traversing required, that means big O 1 will be the time complexity, all right? So this is the only main funda. आपका अगर traversing हो रहा है, right, then you will say big O n, and if the traversing is not required, then you will say big O 1, right? So so when it is big O 1, so ask yourself, can I do this operation directly using head or given pointer? So when you are saying insert at beginning, delete at beginning, insert after a known node, that node traversing required, so big O 1. And the say and when it is big O n, so ask again yourself, do I need to find a node first, right? So if the answer is access nth node, means n number of nodes we have to access. When you want to search a element, right? When you want to insert at a position, or when you can say delete at end. So yes, traversal required. So there you will say big O n. Okay. So simple trick is what? That ask yourself again, okay? Am I walking through the list? If yes, then big O n, right? If no, then big O 1. हमें क्या पूरे पूरे ट्रैवर्स पूरी पूरी लिंक लिस्ट को जाना पड़ेगा, हमें अंदर जाना पड़ेगा उसके? यस. If it is yes, that means big O n will be the time complexity. If no, then big O 1 will be the time complexity. Okay, and apply this also to all types, like in a singly linked list, no backward movement, so more traversing required, okay? And in a doubly linked list, easier deletion but still traversing required, so big O n. Circular linked list, when you are saying, so it needs to find last node, so big O n required, okay? Circular doubly linked list में if tail exist, है ना, अगर आपके पास tail का आपको पता है what is the address, tail मतलब last node का address, if you know very well, the no traversing required, so big O n will be the thing, okay? So this is a simple way to find out the time complexity, right? So if you found this explanation helpful, make sure to like the video and subscribe to the channel for more programming tutorials, and share it with your friends as well. On this channel, we are learning data structures using C++ step by step with clear explanation and coding examples. Also, check out the complete linked list playlist where we covered already all topics like singly linked list, doubly circular linked list. Okay, so watch the full playlist with it will surely help you to understand linked list from basic to advanced level. So the playlist link is also available in the description below. Okay, so in the next video we will now understand stack. It's a very important topic in a data structure. All right. So if you like this video, please share it with your friends and share, subscribe, and like the video. So till then, keep learning, keep practicing, and keep coding. Thank you for watching. See you in my next video.